This video explains how to work with the bootloader and the application on the EM60 module. Now, the bootloader is what allows you to reflash the EM60 just through the USB interface. You saw the USB mini connector in the last video. And then, of course, we have an application here. We have this EM60 test application that I'll explain later. As you know, it serves to production test it. You can do your own test of the EM60 with it, and it can also be a starting point for your own coding your own application. So it can serve as a template. Right now on the screen that you're looking at here, I'm running TerraTerm. That's a free utility that you can get online. And right now it's disconnected. I already set it up to work on the correct COM port with this module. So let me plug in the EM60. I don't know if you heard the beep here. I don't know if that comes through on the video or not. We'll find out. And now we're in the bootloader. You can't see anything here because it took it a while to connect to COM6. And then after 30 seconds, control is passed to the application, which is at 115,200 baud. And let's wait what happens here. We should be coming up on the 30-second point. Oh yes, I see the LED red-green blinking that you saw in the last video. And now there's a little pause. Here it says EM60 test version 1.00, last reset caused by no reason given what caused it. There are some flags in the microcontroller that sometimes show you what it is. Power state is on, and we're now in this control mode. It says press H or question mark for help. Let me press H, and here we go. There we can transmit and receive acoustic data. We can do some monitoring for signal and noise that we use for production testing, or a ping sequence test. What I'm going to do is just to show you some of the capabilities here. I'm going to go to the signal and noise monitoring here, M. And now you see printouts that let us know what the peak strength is of the signal that it sees first here in these columns here at the input of the A to D converter, and it's given in dB respective full scale. So full scale would be 0 dB, so we have minus 24 dB at the ADC input, and then this one here is at the output of an FIR filter that's tuned at 33.89 kilohertz, right, minus 47. And then the averages are minus 31 at the ADC input and minus 60 after the FIR bandpass filter. And there's some additional information that's provided here. What I'll do now is I'll actually hook up a signal generator via an input voltage divider to these input pins here where you hook up normally the sonar transducer. And I'm still switched off here. And what I want you to concentrate on here, let's just look at the averages. We are now at minus 72 dB full scale with the signal generator switched off. I'll switch it on now. And you see it went up to minus 40 dB. That's with a 500 microvolt peak-to-peak input signal, and I can make the signal 20 dB stronger. So we should go to about minus 20 dB, and in fact we're now at minus 20 dB. So that's one of the functions that you can do. You can also do a transmit test. Here, let me go to a transmit test. I'll now hook up a sonar transducer here. Again, you can't see it, but refer to the last video where I hooked it up, you know. So that's connected now. And I can do a ping sequence test. Yeah, let me hook up a 12 volt power too. So that connector P3 right now, I'm hooking up 12 volt power. That's the maximum that you can do with it right now. If you go too high, it tends to reset itself. But you can also operate it just with USB power. Then you get a weaker signal, which is great for initial lab testing. It's not dangerous. If you do hook up your 12 volt, make very sure you're hooking it up to the correct pins. If you have the wrong polarity, there's a diode that protects you. But on P3, there's many other signals and you can do some serious damage. You can blow up your board with the 12 volt if you hook it up wrong. Okay, so I'm now hooked up 12 volt and I can do a ping sequence test, for example. Here, let me do a start frequency of 34 kilohertz. Oops. I should do on my terminal, give me a low echo. I already entered the 34. You cannot do backspace on this one. So this is now 34,000 ping step, so you can sweep through a frequency range, but I'll go 0 hertz or the same frequency, ping length, 1000 microseconds a millisecond, ping interval, let me do 100,000. And I'm going to do 50 pings, that's 5 seconds, and then it's just going to repeat every 5 seconds, you know. So now it's started. So I think you can actually hear that I'm holding the sonar transducer close to my microphone here, and it just goes like click, 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 click. It's really a 34 kilohertz signal, but you can't hear the 34 kilohertz, so you only hear the envelope wave, so it sounds like a knocking type noise. So just for fun, I haven't really tried that yet. Let me sweep through a frequency range. All right, ping transmission done. Now I hit the M again, P to start it again. Let me start at like 4 kilohertz. Ping start frequency, ping step. Let's do in 1000 hertz step. Ping length 100,000. No, also 1000 microseconds, so 1 milliseconds. Ping interval, I'm going to again do 100,000. And I'm going to do 10 tones. Let's see what happens. Oh, you can hear that here. This transducer isn't very efficient in transmit mode for these low frequencies. It's not designed for that, but you can kind of get the idea here. So that's how you interact with that. Giving you a rough idea about, remember, the bootloader, and then it launches the application.